Okay, today's topic is we'll solve the problems in steady state analysis. Earlier we studied theory part. What is the meaning of AC circuit analysis? What are the standard steps? What is the concept behind each step? Now let us go through different varieties of problems which are already asked in different competitive examinations. So let us start with this is one simplest model. One AC source and one inductor, single source, single element, and find this I of t. So what are the standard rules? Convert source into phasor form. So what is the phasor form is 10 by root 2 angle of 0. And inductive reactance is J, omega is 1000 and inductor value 0.05. So you will get 50J. Then what is the current I is 10 by root 2 angle 0 divided by 50J. But this 50J is nothing but 50 at angle of 90. So this is 1 by 5. 1 by 5 is 0.2. 0.2 by root 2 angle of minus 90. But this is in phasor form. We want to convert into trigonometric form. We are converting into trigonometric form because source is already available in trigonometric form. It is inappropriate to express answer in trigonometric form only. But this is RMS. But trigonometric we have to represent in maximum form. So that is 0.2. Then it is sign reference we are following. Sin 1000 t minus 90 degrees. This is equal to minus 0.2 cos 1000 t. So this is the answer. We can also solve this problem using another way. Current formula is I of t is equal to 1 by L. L is 0.05. Then integral input is 10 sin 1000 t dt. So without any limits, integrate, you will get same answer minus 0.2 cos 1000 t. So in this single source, single element, this will take less time, but more than one element, more than one source, then this method is, first method is best method. So depending on the situation, any method you can apply. What is the scope of this problem? Instead of inductor, it can be a capacitor, it can be a resistor, it can be AC source with some angle plus theta or minus theta, it can be cos function with plus theta with minus theta. So all these things we can solve easily or similarly. This is another problem. Two elements are there, two elements. Input Vi is 3 plus 4 sin 100t. 3 plus 4 sin 100t. It looks like a single source, but it is a combination of two sources. Combination of two sources. 3 is the DC voltage source. 4 sin 100t is the AC voltage source. And DC signal frequency 0, AC signal frequency 100. It clearly comes under two sources with different frequencies. I told you one method earlier, that is sixth step. When network contain sources with different frequencies, we should use only superposition principle to find voltage or current or power. Here question is to find voltage, so we should use compulsorily superposition principle only because of two sources with different frequencies. So using superposition theorem, or principle, so first we have to take DC with DC voltage of 3 volts. For DC, capacitor simply behave like open. For DC, capacitor open, and if it is an inductor, it is short. These things we understand in transient analysis, why open, why short. Timing, just remember, for DC capacitor open. So when I draw equivalent circuit with capacitor open, so V01, your capacitor open 1K. Now Vi is only 3 volts. So what is the expected answer now? When capacitor is open, current is not flowing, output follows input. So V01 is simply 3 volts. With the DC, same. Then second, with the AC. With AC, don't use word short or open. Replace capacitor with capacitor reactance. For sin 100t. So what is the capacitor reactance is minus j by omega is 100, and what is the C given? 10 microfarads. 10 into 10 power minus 6. So this is minus 1000 J. Minus 1000 J capacitor reactance. And what is the phasor form of input is 4 by root 2 phasor form 4 by root 2 angle 0. Therefore V02, now using voltage division formula, 4 by root 2 at an angle of 0 into minus 1000 J divided by 1K means 1000 minus 1000 J. So these three zeros cancel. Now we need to simplify this. 4 by root 2 minus J means minus 90. 1 minus J means root 2 angle of minus 45. 4 by, so it will be simply 2 angle of, when this is coming to numerator, plus, so effectively minus 45 degrees. But this is in phasor form. Convert into trigonometric form. So 2 root 2 and input is a sine 100t minus 45 degrees. So what is the output is V0t is input plus, that is something 4 by root 2. This is root 2 angle. Yeah. This 2 is what? RMS. Na? 4 by root 2 by root 2. So root 2 is 2. 4 by 2 is 2. This 2 is RMS. This 2 is RMS. So what is the maximum is 2 into root 2. 4 by root 2, 2 into root 2, same value only, both are same only. So therefore, final answer V0 of t equal to V01 plus V02. That is 3 plus 2 root 2 sine 100t minus 45 degrees. This is the answer. So this is very important model. Input comes under different frequency category. Compulsorily we have to solve using superposition principle. There is another model, 2 sources but 3 elements. Resistor is there, inductor is there, capacitor is there. One AC source, one DC source. Again, 2 sources are having different frequencies. Therefore, again, compulsorily use superposition principle. So, I of t is equal to I1 of t with the DC, then I2 of t with the AC source. With the DC means inductor is short, capacitor is open. Inductor is short, capacitor is open. Or if you want, I can draw again. Inductor is short, capacitor is open. This is 10 volts given, resistance of 2 ohms. Here physically inductor is there, here capacitor is there. But for DC, this is short, this is open. Voltage source not there means short. Voltage source not there means short. Current source not there means open. Now with this, find the I1. So what is the I1? This loop only closed now. So from this, I1 is equal to 10 by 2 is 5 amps. So I1t with the DC is 5. Then with AC we have to find. So if it is AC, inductive reactance, capacitive reactance. Now second case, replace inductor with inductive reactance, capacitor with capacitive reactance. And this voltage source removing means short. So what is the voltage source? 5 cos 2t. This 5 cos 2t change into phasor form. So 5 by root 2 angle of 0. No need to change cos into sine. Only one source that is already in cos form. Let it be in cos reference only. We take it as 0. We are not converting into sine. This current I2, inductive reactance J omega L. J omega is 2, L value 1. So effectively 2 J ohm. Then capacitive reactance minus J by omega. Omega is 2, C value is 1. So minus 0.5 J. So with this you have to find I2. Single source problem always use voltage division, current division concept. Don't go by nodal or mesh analysis unnecessarily. That will take more time. This voltage is dividing between capacitor and these two are parallel. So this equivalent first simplify, and this source is dividing between capacitor and this equivalent. So I am assuming this voltage as some Vx. So what is the voltage here? 5 by root 2 angle 0 is the voltage. This voltage dividing between, so here 2 parallel with 2J. 2 parallel with 2J divided by 2 parallel with 2J minus 0.5J. This is the voltage Vx. But we want current I2 na Vx by resistance. Vx by resistance of 2. So you need calculator to simplify. You will get same answer. The answer 4.47 cos 2t minus 26.56. This is I2. I1 plus I2. I1 plus I2 is the final answer. So like this we can do. Everything is same, only thing is here it takes time to simplify using calculator. This is another important model, important, interesting, special problem. This problem is equivalent to so many problems. Here system is given s plus 2 by s square plus s plus 4, system transfer function h of s. So this h of s given, cos 2t is the input. I can take some value 4 cos 2t. This is input. Input maybe x of t. X of t is the input equal to 4 cos 2t applied. H of s is the system transfer function. YSS, steady state output. You have to find the steady state output. How to find the steady state. So this type of model, when H of s is given, how to find the output. Method 1. Method 1 is y of s is equal to x of s into h of s. This is already in S domain. Input change into S domain, multiply. Then we want steady state output is nothing but L inverse of y of s. So this will take time using partial fractions, etc. Everything you have to do. This is one of the method, but it takes more time. Therefore, I am not using. Second method is using Laplace transform. Y of t is nothing but x of t using convolution. X of t star h of t is impulse response. X of t is the input. By doing graphical convolution between these two functions, you can find output. Any linear time invariant system, this convolution is applicable. If impulse response of the system is known, by doing convolution for any arbitrary input, you can find the output. This is the concept you study in signals and system. But this technique also we can't apply here. It takes more time. Why it takes more time? This h of t is a damped sinusoidal and x of t is a periodic trigonometric function, and finding convolution, time domain convolution is not a simple task. So it takes more time. Therefore, these two methods I am not using. Third method is h of s at s equal to j omega. Steady state analysis always s is with j omega. What is omega depends on input signal frequency. That is 2. So we are simplifying h of s at s equal to j2. What you will get j2 plus 2 s plus 2 na numerator s square j2 square plus j2 plus 4. J2 square is how much? Minus 4. This minus 4 plus 4 cancel. 2, 2, 2 also cancel. Numerator 1 plus j. 1 plus j is what? Root 2 angle 45 degrees by denominator only j, 1 of angle 90. So this answer is root 2 angle of minus 45 degrees. So we just simplified h of s at s equal to j2. It is coming as root 2 angle minus 45. What is this root 2, RMS or maximum? This root 2. This root 2 not RMS, not maximum. Why? RMS maximum is applicable to signal, not to the system. System we never say in terms of RMS or maximum. Signal only, input signal or output signal expressed in the form of RMS or maximum. So don't think root 2 is RMS or maximum. Root 2 is the value. So system value simplified to root 2 angle minus 45. Now output, what is the input signal phasor form? Input signal phasor form is 4 angle 0, or I will take here some value cos 2t plus some 20 degrees. So cos is there, I am taking cos as a reference. 4. This 4 is maximum. Let it be in maximum. So what is the angle? 20. And this value reduce it to root 2 angle minus 40. What is the output will be? This is in R1 angle theta 1, R2 angle theta 2. Output is nothing but multiplication of these two. So both the gains you can multiply. So when you are multiplying, what you get? 4 root 2 angle. This is plus 20 minus 45, effectively minus 25. What is this 4 root 2 is RMS or maximum? It is in maximum. Why it is in maximum? This 4 already in maximum. Don't use RMS or maximum here. Output is nothing but product of these two. So 4 root 2 is the maximum. And plus 20 minus 45 is becoming minus 25. So what is the final output? 4 root 2 cos 2t minus 20 is the answer. What is the other easy method? Input signal, this 4 is multiplied with root 2. So 4 root 2 cos 2t plus 20 further delayed by minus 45. So plus 20 minus 45 is what? Minus 25. So straight away also you can answer. So simplify h of s at s equal to j2. This multiply with input and straight away you can write the output. This is the best shortcut simple technique. But this technique is valid only in steady state. The steady state only s equal to j omega valid, and in the question is to find steady state output only. Therefore, I can apply this method. What is the advantage of this method? The system can be the system now input. And this is out. How many ways system can be described? It can be h of t impulse response or differential equation. D square y by dt square minus 10 dy by dt, like the differential equation. Or it can be h of s. So these are the three different methods: h of t impulse response, differential equation, system transfer function. System can be described in so many ways. But this notation generally we study in signal chain system. If it is a DSP, it can be h of n, and a difference equation. Difference. This is differential, this is difference equation. Or it can be h of z transform. So this we study in DSP, digital signal processing. So digital domain we come across these names. Then it can be control system, block diagram. Can be a block diagram. It can be a signal flow graph. One block is given, you can find a transfer function. Or so many blocks are there, convert into signal flow graph, apply Mason's gain formula, and again find the transfer function. So these, or it can be state variable or state equations. state equations. So there you study how to find a transfer function from the state equations. So you study all these things in control system. Or it can be a network. It can be a network. So if it is a network, obviously you study in network subject. So system can be described in any one of the form. In any one of the form, what is the problem we solved? If it is h of s, I explained how to solve. Now, if h of t is given, convert into h of s. Difference equation given, convert into h of s. So all other given models convert into h of s. Follow that method, find out the output. So how to convert any given form into h of s. Example, this h of t convert into h of s. Impulse response, how do you get h of s? Apply Laplace transform. Using Laplace, you get this. Difference equation, how to get h of s? A difference equation can be like 10 d square y by dt square minus 5 dy by dt plus 2y is equal to some 6x of t. X of t is the input, y of t is the output. Apply Laplace transform. Get 10 into s square y of s minus 5 s into y of s plus 2 into y of s is equal to 6 into x of s. When you are finding transfer function, we take always initial conditions 0 by default. What is the transfer function definition? It is ratio of Laplace transform of output by input. This is nothing but h of s. H of s is a system function or transfer function. So what is the answer? 6 by 10s square minus 5s plus 2. This is h of s. So I explained how to convert differential equation into h of s. So convert this into h of s. Next, if it is given h of n, h of n is given, apply z transform, you will get h of z. Or if difference equation is given, again apply z transform, you will get h of z. Difference equation. How it looks like? 10y n minus 2 minus 5y n minus 1 2y of n is equal to 6x of n. What is the name of this? Difference equation. Apply z transform. 10 z power minus 2 into y of z minus 5 z power minus 1 into y of z plus 2 y of z is equal to 6 into x of z. So what we want? H of z is nothing but y of z by x of z. This is the z transform. So 6 by 10 z power minus 2 minus 5 z power minus 1 plus 2. If you compare h of s and h of z, here 10 s square na. So z power minus 2 becoming s square, z power minus 1 s, 2 as it is. So using this simple mapping, h of z also converted into h of s. using the simple technique, you can convert h of z into h of s. Now, so difference equation to h of z, one is h of n to h of, then difference equation to h of z, h of z to h of s, h of z to h of s. So all these things converted to h of s. Then block diagram convert into signal flow graph, apply Mason's gain formula, obtain the transfer function. The transfer function is actually m of s, na? M of s equal to g of s by 1 plus g of s h of s. This m of s is nothing but overall transfer function. Na? Overall transfer function that can be considered like a h of s. Not control system, this h of s. Signal sign system h of s means system function. So this m of s considered like a h of s in signal sign system. Then state equations also convert into transfer function that is like a h of s. The last one, if network is given, if some network is given, maybe some resistor and capacitor. Just one example I am taking. Capacitor and resistor. This is Vi of t, time domain, V naught of t. But I want to transfer function. When I want to transfer function, V naught of s by Vi of s. So S domain. What is S domain? 1 by SC. So using voltage division, 1 by SC by R plus 1 by SC. So simplify this. You get 1 by SCR plus 1. How this looks like? 1 by CR by S plus 1 by RC. Na? So what is this? It is a transfer function H of S. Now you understand how given network convert into H of S. So this network how to convert into H of S. Block diagram to signal flow graph to H of S. Then state equation to H of S. So any given form I explained how to convert into H of S. Input is given, H of S is known, then easily you can find output with the help of this method just now I explained. So using that. What are the different inputs possible? Input can be only DC. Input can be only AC or single AC source. It can be DC plus AC. Or it can be AC multiple. AC with the different frequencies, omega 1 and omega 2. It can be, input can be impulse. It can be impulse. It can be step. It can be ramp. Can be ramp. So these are all different possible inputs we may apply. Don't take triangular wave, square wave, sawtooth waveform because that contain too many frequency components. So for these possibilities, how we can find the output? If input is only DC, how to find output? For example, x of t is only 4. If it is only 4, what is the frequency omega? 0. If it is 0, s value 0, s square 0, s 0, 2 by 4 is how much? 0.5. Na? What is the input applied? 4. 4 into 0.5 is how much? 2. Answer. So if input is only DC, frequency 0, simplify h of s and multiply, you get the answer. The same way, if input is only DC, using that technique, you can find. With the AC already explained. If it is DC plus AC, DC plus AC means it comes under different frequency category. Take DC alone, find output. To AC alone, find output. To add those two, using superposition principle, find out. AC sources with the frequencies of omega 1 and omega 2. Again with omega 1 find the output, with omega 2 find output, add them. Like that you can find. If input is a impulse function, if input is impulse, what is the response named as a impulse response? Impulse response is nothing but finding h of t. H of t is nothing but L inverse of h of s. What is given? H of s. Just to L inverse of that you do it, you will get h of t. H of t is named as a impulse response. So easy. If step is given, a simple technique, differentiate the step function. When you differentiate step, you get a impulse. Derivative of step is a impulse. Now, how many times you are differentiating? One time. So step response is nothing but integration of impulse response. To get the impulse, you need to differentiate one time. But what we are looking for a step response, integrate the impulse response. Integration of impulse response is nothing but a step response. But how do you get h of t? L inverse of h of s, integrate, straight away you get the impulse response. If input is a ramp, first differentiate one time, then again differentiate second time. Derivative of ramp is a step. Derivative of step is a impulse. How many times we are differentiating? Two times. Therefore, ramp response is nothing but double integration of h of t. Double integration of h of t. Why two times integrating? Because we are differentiating two times, integrate two times. So double integration of h of t is nothing but a ramp response. So how many inputs we applied? 7 inputs. How many ways system can be described? 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. System can be described in 10 ways. Inputs can be 7 types of inputs. Then what is it can be eighth one, exponential input. Eighth one is exponential. It can be exponential. Exponential input. So if input is exponential, the best technique is like exponential input to e power minus 8. So what is Laplace of this? 1 by s plus a. X of s find out. H of s is available. Multiply. Inverse of that is nothing but output. So that is what y of t is nothing but L inverse of x of s and h of s. Because this exponential, if you differentiate any number of times, you get exponential only. If you integrate any number of times, again you get exponential only. So that is the reason when if input is exponential, you go by Laplace transform and find the output. Or it can be doublet. The ninth one, doublet. What is doublet? Derivative of impulse function. Now don't differentiate this. Here you have to integrate. What is integration of doublet is impulse. But doublet response is nothing but derivative of impulse response h of t. To get impulse, we integrated. To get the doublet response, differentiate. It is similar to this. If step is given, to get the impulse, we differentiated. To get the step response, reverse integration. Here, to get the impulse, beginning integrated. To get back original, you have to differentiate. So d by dt of h of t. So how many types of inputs we have taken? 9. How many systems? 10. So what is the output? 9 into 10 equal to 90 models. 90 models solved. Not 90 problems, 90 models. It can be different input to different systems. So that's why this model is very important. So many exams, this concept is already asked, sometimes one way, different way. So it is a combined concept of signals and system, DSP, control system and network. Ten d square y by dt square minus 5 dy by dt plus y of t is equal to 6x of or 6 sine or otherwise 6x of t. This is the differential equation and x of t is equal to 2 sine 10t. Find y of t. So this is one of the problem in mathematics. How MathSR will solve this problem? So there is a way to solve particular solution. Particular solution with constant, with exponential, with constant to the power of variable, variable to the power of constant, with AC. So that method you will explain to find the y of t. So now using my method, first find the h of s. How to find h of s? Apply Laplace transform. Take the ratio y of s by x of s become h of s. So this h of s you got it. H of s you got it. What is the input given? 2 sin 10t given. So already one problem solved now with the input AC. How to find output? If you do this in 1 minute, you can solve. But using math procedure, it takes 4-5 minutes. So this is the technique you can apply. So I summarized, even including mathematics also. So 11, 9 into 11, 90, 99 models. 99 models. So that is the specialty of this problem. So this is another problem. So single inductor, single source. What is given is if Vs equal to V naught sin omega naught t, ammeter is reading RMS value of I naught. Is AC source. So this is AC. AC ammeter will read obviously RMS. So this I naught by default RMS. Single inductor is connected. Ammeter is, of course, it will read the current of RMS I naught. Single AC source, single inductor, one ammeter. It read RMS of I naught. Now in place of Vs, if it is minus V naught sin omega naught t plus 2 V naught sin 2 omega naught t minus 3 V naught sin 3 omega naught t and so on is applied, what is the ammeter reading? That is the question. You can do so many mistakes. One student solve like this. If input is V naught sin omega naught t, what is the RMS got? RMS is I naught. If it is minus V naught sin omega naught t, student think that minus. Then what is second one? Frequencies are different, na? So they apply superposition principle. And 2 V naught sin 2 omega naught t. What is the current? Current is nothing but voltage by reactance. Na? Inductive reactance will be double because XL is equal to J omega L. Frequency double. So reactance double. Input voltage double. Na? So numerator is increased by 2. Denominator also increased by 2. Again ratio remain same. But this is plus. So plus I naught. Like that minus 3 V naught. Voltage 3 times, frequency 3 times. Again ratio same. Minus I naught. Fourth one plus I naught. Then add them. You will get 0. So one option available is 0, which is wrong. What is the mistake they have done? Whether input is positive or a negative, RMS is always positive. With the first one plus I naught, second one plus I naught, third one plus I naught, fourth one also plus I naught. So they add. V bit is 4 I naught. This is also wrong. What is the mistake they have done? RMS values should not be added. Additive property, scaling property cannot be applicable because RMS is a nonlinear function. Individual values you cannot add. This is second mistake. If you do that, you get 4 I naught. Third, some students solve like this. So root of I naught square. This I naught is RMS, na? So I naught square plus I naught square plus I naught square plus I naught square. I naught is RMS. Individual values already available in RMS. So root of this. So what you get? Root of 4 I naught square equal to 2I. This is correct. 2I naught is correct. Some students, they don't see in the exam hurry this omega naught 2, omega naught 3, they don't see. So with this they take I naught, with the second 2 I naught, then 3 I naught, then 4 I naught. Accordingly they do it. So that will give some other answer. So be careful. Okay. So this is asked in IES exam. Whatever models I am solving, it is already asked in some exam. So it is a collection of different models. Specialty of my teaching is solving different types of problems, models, not the stereotype, same model, 10 problems. Some teachers solve same model, but 10 problems. How I am solving 10 different models. That is the special. So here some network is given, RC as parallel. Input Vp cos T by RC given, V naught is asking. So this is the problem. What is the earlier I told you? When network is given, immediately you have to find transfer function. Transfer function input is a sine wave. Use that method. So what is the transfer function straight away? V naught of S by Vi of S. S domain, this is 1 by SC, na? So R parallel with 1 by SC divided by R plus 1 by SC, R parallel with 1 by SC. This you have to simplify. This is nothing but H of S. So you will get SCR by SCR square 3 SCR plus 1 will come. Plus 1 will come. So I am not simplifying. Just simplify 3-4 steps, so then you will get this. Then what is our standard procedure? Simplify H of S at S equal to J omega. What is omega? Depends on input signal. Cos T by RC. So what is omega? 1 by RC. J omega. So omega is so J. So simplify this. S equal to J. Omega is 1 by RC into RC by J 1 by RC into RC square plus 3 J 1 by RC into RC plus 1. So this RC cancel. What is numerator? J. What is denominator? J square. J square is minus 1. minus 1 plus 1 cancel. So 3j is equal to 1 by 3. So h of s is simplified to 1 by 3. What is output now? Input multiplied with 1 by 3. So Vp by 3 cos t by Rc. H of s not giving any angle. Like this, you can get the answer. So now I stop it here. We'll continue next class some more problems.